In this video, I'm going to give you some tips for solving the ALEKS problem called solving moles to moles limiting reactant problems. There are a lot of different variations of this problem, so it's going to be difficult for me to make a video that's going to help you answer the specific problem that you have. However, I'm going to give you some general tips, things that you can do no matter which version of the problem you have, or things that you need to do. No matter which version of the problem you're looking at, the very first thing you need to do is write and balance a chemical equation to describe the reaction in the problem. ALEKS has done a really good job of making, I think, making the reaction really clear. It provides the chemical formulas for all the reactants and the products. All you have to do is just balance it. My reaction is NH3 reacting with O2 to produce N2 and H2O. And it is not going to be necessary for you to include the states in any of this. That's not going to be relevant to solving the problem. So I am going to start by balancing my hydrogen. I think those are going to be the trickiest ones to balance. I've got 3 on the left and 2 on the right. So I'm going to put a 2 in front of the NH3 and a 3 in front of the H2. That's going to give me 6 hydrogen on each side. My nitrogen are currently balanced right now, and my oxygens are a little bit wonky. So I think what I'm going to do is put a 4 in front of my NH3. That's going to give me, or require me to have 2 and 2. I've got 12 hydrogen, so I'll put a 6 here. And then I have 6 oxygen, so I'll put a 3 here. This equation is a little bit tricky to balance. I know I went through that pretty quickly, but I'm sure that at this point you're really good at balancing equations, so you'll be able to get yours balanced fine. So step number 1, write and balance an equation. Step number 2, you have to figure out which is your limiting reactant. So you're going to have 2 reactants in this equation. ALEKS is actually going to give you the quantities of each of those reactants. I have 3 moles of NH3 and I have 7 moles of O2. And I'm just going to write those numbers underneath my equation. 3 moles of NH3 and 7 moles of O2. No matter which version of the problem you have, you definitely need to figure out which of these 2 is your limiting reactant. And the way that you go about solving that, determining limiting reactant, everybody's kind of got their own way of doing it. I'm going to show you how I go about doing it. It's a little bit more tedious than ALEKS's description, but I think it's a little easier to understand. So what we're going to do is 2 stoichiometry problems, and we're going to figure out how much N2 we can make. I'm choosing N2 specifically because ultimately my problem is asking me a question about N2. So I think it's going to be helpful in the long run. But honestly, it doesn't matter which product you pick to do this. How much N2 can I make from my 3 moles of NH3? That's my quantity of one of my reactants. And then we're going to do the exact same problem. How much N2 can I make from my other reactant, 7 moles of O2? Now again, this is not how ALEKS describes it. It is a little bit more tedious than ALEKS's method, but I think it's a lot easier to understand. So we're just going to treat this as 2 totally separate stoichiometry problems. How much N2 can I make from 3 moles of NH3? We're going to start by writing the quantity that has been given to us. That is the 3 moles of NH3. Again, if you got kind of confused about where does 3 come from, that's how much NH3 I have. All right, so 3 moles of NH3. I want to calculate how much N2 I can make. So I'm going to convert into moles of N2 from moles of NH3. This is my conversion factor so that the moles of NH3 are going to cancel out. These numbers here are the stoichiometric coefficients. This is why we have to start by balancing the equation. 2 moles of N2 for 4 moles of NH3. The moles of NH3 are going to cancel, and I'm going to be left with 6 divided by 4, not 0.6. 3 times 2 is 6 divided by 4, 1.5 moles of N2. This is how much N2 I can make from 3 moles of NH3. Now we're going to solve the same type of problem. How much N2 can we make from our other reactant, 7 moles? I have 7 moles of my other reactant, O2. 7 moles of O2. Again, conversion factor, converting into moles of N2, converting out of moles of O2, using the stoichiometric coefficients from the equation that we balanced, 2 moles of N2 over 3 moles of O2. The moles of O2 are going to cancel, and I'm going to get 7 times 2 is 14 divided by 3 is 4.7 moles of N2. So what we've done here is calculated the amount of O2 that we can make from our given quantity of NH3 and the amount of N2 that we can make from our given quantity of O2. The lesser of the two, so in our case, that's the one we want to focus on, the lesser quantity, the one that we want to focus on is the lesser quantity. We're comparing the quantity of N2 and the quantity of N2 from both of these hypothetical situations. We want to focus on the smaller quantity. That smaller quantity is what tells us our limiting reactant. So what this is saying is that the amount of NH3 we only have enough NH3 to produce 1.5 moles of N2. We have enough O2 to produce a ton of N2, but it's never going to happen because we only have enough NH3 to produce 1.5 moles of N2. So NH3 is our limiting reactant. I'm going to highlight that. And again, no matter which version of the problem you're looking at, step number 1 is to write and balance the equation. Step number 2 is to figure out which is your limiting reactant. Once that's done, then you can actually solve the problem that ALEKS is giving to you. So I'm going to erase this stuff to make some more room. And then now let's take a look at the problem that ALEKS is asking. So it's asking, could half of the NH3 react? That's kind of a tricky word. The way that I want to think about that is there enough of my other reactant, O2, to react 1/2 of my 3 moles of NH3. That's, I think, a clearer way of wording the problem. 1/2 of 3 moles is 1.5 moles. That's even clearer of NH3. So we're gonna think about the problem in this sense, and it's possible that maybe you'll have this exact wording, and this is how I want you to reword it, or you may have something else that's kind of confusing like this. Find a way to reword it to make it a little bit clearer. It's going to be clearer if you can put an actual quantity in there instead of just like half or a quarter or whatever. So let's answer that question first. Is there enough O2 to react 1.5 moles of NH3? So how are we going to solve this problem? We know that we're trying to react 1.5 moles of NH3. Let's figure out how much O2 that requires. So that's what we're going to do. We're going to convert from NH3 into O2 using the stoichiometric coefficients, 3 moles of O2 over 4 moles of NH3. We'll use the calculator for this. 3 times 1.5 divided by 4. This tells us 1.125 moles of O2 are needed in order to react with 1.5 moles of NH3. Do we have 1.125 moles? Yeah, we have 7. So yes, half of that NH3 could react because we definitely have enough O2. Now, second question, if you answered yes, we did, how many moles of N2 would be produced after half of the NH3 was used up? So again, instead of saying half of the NH3 was used up, let's just say 1.5. After 1.5 moles of NH3 react, how many moles of N2 would be produced after 1.5 moles of NH3 reacted? 1.5 moles of NH3. We want to figure out how much N2 we can produce from that quantity of NH3. Now again, these things that I'm doing here are specific to this exact problem, but hopefully watching me solve these tricky worded questions here are going to help you with whatever version of the problem you have. So instead of saying half, I'm saying 1.5 because I was told that I had 3 moles. Half of 3 is 1.5. How many moles of N2 would be produced? So here's my conversion factor from NH3 to N2 using the stoichiometric coefficients, 2 moles of N2 for every 4 moles of NH3. And 1.5 times 2 divided by 4 is 0.75. It says round that to the nearest 0.1. which is 0.8 moles.